Hello, welcome to the Zowe session of the Open Mainframe Project 2021 Summer Mentorship Program. I'm Pavlin Zahari from Broadcom. I joined Zowe in 2018. This year, I was honored to become one of the mentors for the Open Mainframe Project Mentorship Program. It is my great pleasure to give you an introduction about the Zowe session and to the Mentorship Project's presentation. Before I move further, please allow me, on behalf of all Zoe mentors, thank to the people from Open Linux Foundation who made it possible for us to join and finish the mentorship program. We were provided with extensive documentation and guidance, and you gave us answers and support when we needed. We learned a lot from it. Thank you very much. Today, we're going to demonstrate to you the results of 5 valuable contributions to the Zoe ecosystem of interfaces, SDKs, and client tools. All right, let's start with an introduction to Zoe. Who actually this Zoe is anyway? Zoe is the coolest open mainframe subproject. It was started a few years back by major mainframe software vendors like IBM, Broadcom, and Rocket Software with the aim to make the mainframe so comfortable and safe to access from outside that everyone would feel alright to let their children play with it. Now, I guess I'm a bit biased. Maybe not everyone, maybe just most of the people. Zowe is an integrated and extensible open source platform for access to ZOS system resources and services. Zowe comes with ready-to-use applications out of the box and offers modern interfaces to interact with ZOS systems and applications. You can use these interfaces as delivered or through plugins and extensions that are created by third-party vendors. Last but not least, you can extend Zowe yourself. It is all in your hands. The basic Zoe architecture diagram helps to understand better the improvements contributed by the OMP Mentorship Programs project. The default Zoe installation package consists of several top-level components: the Zoe application framework, Zoe API mediation layer, Zoe CLI, Zoe Explorer, and Zoe SDKs. There are a couple of them, and 2 more added during this mentorship program. You can learn more about the Zoe architecture and components at the web address under the architecture diagram. Please visit. Before I introduce the mentees and their projects, I'd like to express my appreciation of the attitude and qualities of these young people. First of all, they are very brave. I guess they didn't exactly understand what they are signing for, but that's alright. Otherwise, we may end up with no one to mentor, which would be a pity somehow for the mentorship. Second, by choosing to participate in the summer mentorship program of the OMP, they devoted their first semi post COVID summer holidays to create something really meaningful. Thank you. Third, they are quick learners. They jumped into a whole different world with many specifics and complexity beyond the usual school projects, and soon they were able to gain speed and deliver real products. Last but not least, the mentees demonstrated a strong will to complete the projects regardless of some serious obstacles and turbulences of different. Here they are: Nikun Goyal from India, Michal Malik from Czech Republic, Svetang from India, Kumar Saurabh from India, and Muhammad Ali from Nigeria. They joined Zoe to create 5 different projects. Nikun created a Java client SDK to provide Java developers an SDK to easily interface with a backend mainframe from any computer that has a JVM. Michal Malik, he defined the IntelliJ IDEA plugins testing platform and CI/CD pipeline using GitHub Action. Svetang, he created a Slack bot to interact with Zoe using Node.js Zoe SDK to perform mainframe tasks like downloading log, issuing commands, and query status of job. Kumar, he created a metrics service and dashboard UI so administrators could monitor the health status and usage of API services running behind the API mediation layer. Muhammad Ali, he created a VS Code template extension that will serve as a guidance to help extenders build Zoe related VS Code extensions. On this slide, you can see how the Mentees projects plug into the Zoe architecture landscape. Uh, Please note that four of the five projects address client side, which is a good sign that Zoe matures and moves closer to the users, as opposed to the wild beginnings when there were not sufficient services to expose. So everyone was busy working on the server side. And some of the key learnings that we collected during the course of the project. Read the documentation. Maybe the answers are already given. Maximize the preparation phase utilization. Don't miss it. Minimize project dependencies. Plan for end of school year duties and project overlap. Adjust scope for summer holidays arrhythmia. Many people are missing in the summer. Intensively communicate with fellow mentors and mentees. Plan carefully for a one man show and count for lack of knowledge about them. Well, enjoy the Zoe session presentations. Thank you for your attention.
Greetings. Welcome to the mentorship session for Zoe Client Java SDK. Over the course of next 5 minutes, we'll be going over the progress that we have made in the mentorship program for Zoe Client Java SDK. For the introductions part, this project was mentored by Leonid Baranov, who joined Broadcom in 2020 and is has been working on Zoe Brightside and VS Code plugins. I was fortunate enough to be granted the opportunity for becoming a mentee for this project. My name is Nikunj, and I am studying electronics at JC Bose University of Science and Technology. My interests lie in a variety of fields from blockchain to web development. For an overview about the problem, currently there are many client SDKs for Node.js, Python, Swift, and other languages as well. But we notice that there are a lot of Java developers who do not have an SDK for Java and have to implement REST API communication with Zoe services by hands. So we just thought of this project so that it would make the work of such developers easier. This SDK expands the development community potential to build apps and scripts on Zoe Java SDK. It also provides a foundation upon which an IntelliJ IDEA Zoe plugin could be developed. For the milestones part, we aim to have a high level Zoe client SDK design as well as REST API interaction with ZOS mainframe REST API implementation. Other than that, we also aim to have the Zoe client Java SDK MVP done. For my achievements, I was able to set up Mockito unit test framework and was able to add unit tests to the existing functionality. I was also able to implement the functionality of creating a dataset and its members, listing dataset and its members, and deleting a dataset and its members. Other than that we also have the functionality of implementing. We also have the functionality of loading and modifying a dataset's content. And to some extent, I was also able to ex- expand managing jobs functionality. My key learnings were that I was able to learn about Mockito unit test framework, about Java classes and interfaces, about concepts like inheritance, OOPS, sort principles, etc. And I was also able to learn about ZOS mainframe REST API and its client Java representation. My favorite part of the mentorship is when I got access to the ZOS mainframe test environment. And after that, when I tried to list datasets and its members, I realized that the functionality was working properly and the response from mainframe was also passed properly. This was the first solid outcome of our mentorship and it was really exciting. As far as my advice for other mentees is concerned, I'd just say that please do not hesitate to ask more and more questions, however dumb they might be seem, because ultimately they help you a lot to avoid mistakes that can be easily avoided. Now let's have a demo for the project. I have a pre-made dataset called test dataset. You'll see it is building over here, and you can see that the output will have an array of datasets, and it will have a dataset by the name test in that. See, and 200 response means that we have received a successful response. This array is the members array. Since we do not have any members right now, it is empty. Now we'll try to create a dataset, and we'll see how it goes. Yep. So now you can see that there is a 201 response. That means that the test one dataset was successfully created. If we try to run list datasets again, we'd see that we were successful in creating a dataset. See, test one dataset is there. Now we can also try out the delete dataset functionality. It will delete the dataset. We'll more or less see a 204 response that would indicate that our dataset was deleted successfully. See, now we can try listing the datasets again to confirm that the dataset was deleted. Now you will see only one dataset, that is the test dataset in the datasets array. See, we have a lot of more functionalities, but unfortunately we are bound by time constraints. But please feel free to reach out to me in regards with any functionalities or any other functionalities that you would like to see in this project as well, and we'd be happy to work on it to implement it. Thanks a lot for being a part of this session. Thank you.
Good morning. My name is Michal Malik and I would like to introduce you to the Zowe Toolkit plugin for IntelliJ project. First thing first, it must be said that soon after the mentorship started, it has been discovered that the IBA group is already working on a similar plugin. Afterwards, it was decided that this plugin will move under the Zowe. The plugin is still being reworked and it lacks tests. Because of this, it was decided that my work is to look into the possible ways to test the plugin so that the test can be written as soon as possible once the plugin is finished. In this short presentation, I will briefly go over unit, API and UI tests as well as GitHub actions. Let's start with unit tests. They are not recommended. Actually, IntelliJ doesn't even recommend mocking because in their words, it's difficult to mock all of the interactions with IntelliJ platform components that the plugin needs to have. That being said, they provide the mock application class which can be set up instead of the regular application, and as long as the class which you want to test doesn't rely on additional components, it can be easily unit tested. What IntelliJ does recommend is smoother level functional tests, which can be used to test API. They use headless IDEA and real implementations of the plugin components. IntelliJ has also built-in functions which allow us to take a file as an input, execute a feature, and then compare the result. What might interest you is that mocking can still be unavoidable. At the very least, in the plugin for ABA it was. The problem was the license agreement. In order for the plugin to function properly, the user needs to accept to certain terms and conditions. The acceptance is done on UI level. But because we use headless IDEA, we need to accept it on API level. We did a workaround by mocking the user agreement. The plugin's UI can be tested by the IntelliJ UI test robot. The robot sets up an IDEA with the plugin called robot server. And then it runs asynchronously remote robot, which tells the server on what it should click or what it should type. The UI tests use XPath query language to locate buttons, labels, components, and so on. What is not implemented in the UI test robot is a way to close various dialogues once the test fails. In other words, there is a need to implement a teardown method which closes open dialogues and readies the robot server for the next test. As a part of my work, we have implemented some preliminary form of the teardown method for the IPA plugin. Lastly, let's talk about GitHub Actions. It's a way for us to run tasks on GitHub on events such as push, merge, or pull requests. In other words, on pull requests, it's possible for GitHub to run tests and check whether all of them pass before merging. The tasks run on virtual machines called runners. The runners can be GitHub hosted or self-hosted, meaning you can run it on your own machine. We are able to run unit and API tests on GitHub runners. Unfortunately, for now, we can only run UI tests on self-hosted runners. In conclusion, I was supposed to look into the ways the future plugin could be tested. I identified some classes which might be possible to unit test, look into how the API tests work and mock the license agreement so they can be actually run in the version of the code that I have received. I also researched the UI test robot and implemented a preliminary teardown method for closing dialogues. Lastly, I have put the tests into a pipeline provided by GitHub called GitHub Action. One of the things that remain to be dealt with is to figure out how to run UI tests on GitHub hosted runners.
Welcome everyone to the Open Mainframe Summit. This is Zowe Mentorship session and the project is Slack to Zowe integration and I'm your host Shwetank. The team for this project was Joe Winchester, who was my mentor, and me, Shwetank, as a mentee. The aim for this project was to demonstrate how mainframes can be integrated to modern day communication tools like Slack with the help of Zowe. Before we proceed further, let's talk about Zowe first. So, what's Zowe? Zowe is an integrated and extensible open source framework for ZOS. It comes with a set of APIs and OS capabilities that applications can build on, and it also includes some applications out of the box. So, how does it work? The user sends a message /authenticate to the bot, and then suddenly a pop-up appears which asks for the host mainframe credentials. After successful verification of the credentials, the user can give any command to the bot and the bot will run that command for the user and give back the output of the command directly from the Slack, and the user does not have to leave Slack to interact with the mainframes. So, how does it work internally? After receiving the user input, the Slack app or the Slack bot sends that message to our REST server in the cloud. The REST server in the cloud, with the help of Zowe client library, talks to the mainframe and sends the command. After receiving the response from the mainframe, the REST server sends the response back to the Slack bot, which then sends the response to the user back. So, how does this app benefit the existing users? The users can talk directly to mainframes without switching away from Slack and could easily do the interaction in front of the whole group instead of just sending the screenshots of their terminals. So, what's the conclusion? The conclusion is that mainframes can be integrated with any tool using Zowe.
Hello everyone and welcome to the Zowe mentorship session of the Open Mainframe Summit. I'm Kumar Saurav Raj and this is the Zowe Metrics Dashboard or API Mediation Layer project. The team behind this project consists of my mentor Carson Cook, who is a software engineer at IBM and experienced in student leadership and advocacy. And this is me, the mentee, a computer engineering undergrad currently in my senior year who loves to contribute to open source and enjoy working on distributed systems, cloud technologies, and DevOps. Also, this project would not have been possible without the invaluable guidance and support from the entire API Mediation Layer squad. Let's start by going over a brief overview of the project. The aim of the project is to create a microservice that will collect and display transport and system level metrics for the API Mediation Layer services. System administrators using Zowe and the API Mediation Layer want to understand the overall health, security, and performance of the mediation layer and its onboarded services. Currently, there is no integrated way to view metrics that give insight in these areas. The technologies that are related to this project are microservice architecture, Java, Spring Boot, Spring Cloud, React, RabbitMQ, Docker, Kubernetes, and more. Let's dive deeper into what the Zowe API Mediation Layer is about. The API Mediation Layer provides a single point of access for mainframe service REST APIs. The API Mediation Layer offers enterprise cloud-like features such as high availability, scalability, dynamic API discovery, consistent security, a single sign-on experience, and documentation. The API Mediation Layer facilitates secure communication across loosely coupled microservices through the API gateway. The Discovery Service enables us to determine the location and the status of the service instances running inside the API Mediation Layer ecosystem. The API Catalog provides a user-friendly, easy-to-use interface to view all discovered services, their associated APIs, and Swagger documentation. Here is how the architecture of the API Mediation Layer looks like. Now let's dive deeper into the project details. So as we already discussed that the system administrators would like to be able to monitor the overall security, health, and performance of the installed mediation layer and its services. This project is an effort towards that by leveraging Netflix open source technologies like Hystrix and Turbine. A single dashboard is to be developed that clearly shows individual services as well as low latency aggregate stream information via Turbine for transport level information like request rates, error rates, etc. The main features or the requirement for this project were to maintain security of the Zowe API mediation layer and its applications being monitored, allow administrators to see HTTP metrics of REST API endpoints of each service onboarded onto the API mediation layer, register to the discovery service, and metrics are to be streamed to provide real-time metric gateway authentication and support gateway SSO and use gateway to route users to the metric service UI. Here is how the proposed architecture with the metric service looks like. The various services in the API mediation layer expose their individual metrics via histories. Turbine then aggregates all of these various historic streams into a single stream, which is then consumed by the metrics service and could be visualized by the embedded metrics dashboard. This is how the API gateway looks like. This is how the login page of the metrics service looks like. And this is how the metrics dashboard itself looks like. We could clearly see the metrics for various endpoints in various services on the metrics dashboard. Let's go over the project demo now. Let's open the API gateway page and navigate to the metrics service. This is the metrics service login page, and we could enter the user ID and password here. The metrics service is protected by the gateway authentication. Entering invalid password does not let us get it into the metrics service. This is the metrics service dashboard. We could see the HTTP metrics for the different endpoints in different services on this page. Let's make a couple of requests to different endpoints so that we could see the metrics change on the metrics dashboard page. As we see here, the metrics and their visualizations have changed for various endpoints. Please feel free to connect and reach out to me for discussions on this or other similar projects. I'm always open for collaborative and learning opportunities. Thank you for listening.
Hello, my name is Muhammad Ali. I will be presenting what we are able to bring up together with my mentor Daniel Kileski throughout the mentorship period. A little about me. As I have said, my name is Muhammad Ali. I'm a final year statistics student at Kano University of Science and Technology within Kano State, Nigeria. Beside my school activities, I started learning Python programming language due to its English-like syntax over other languages, and start to develop interest in software development. I previously participated in the Master the Mainframe program, where I learned and displayed the fundamental mainframe skills. I then applied for the Open Mainframe Mentorship program to expand my knowledge of the mainframe technology. Let's have a little about Zowe. Zowe is an integrated and extensible open source framework for ZOS. Zowe, like Mac OS or Windows, come with a set of APIs and OS packages that applications built on, and also includes some applications out of the box. Zowe is composed of several components, each improving the learning ability, accessibility, and possibility of mainframe development. The main project, Zowe Explorer Extension Templates. In this project, we made a sample VS Code extension that is similar to Zowe CLI sample but tailored for mainframe. It has a direct connection to a back-end service. The back-end service used in the project is Zowe Sample API service. The project entails the CLI plugin, a sample Zowe CLI plugin which calls the sample Zowe REST API. API on ZOS, the Zowe Sample API service helps you to build a new Zowe component, REST API, SDK, in TypeScript and JavaScript to make your service callable via the Node.js applications and script. The SDK support both the Zowe CLI plugin as well as the Zowe Explorer VS Code extension. An extension for VS Code allows for graphical interaction to ZOS services. Let's have a description of the whole project. A user interacts with the Zowe sample VS Code extension or Zowe CLI sample plugin. The common Zowe sample SDK code reads config or profiles. Then call the Zowe sample REST API with optional query parameters. The hello message response is returned via the API to the SDK and to the end user. That is through the sample VS Code extension. On the right hand side, we have a demonstration on how to run this program. First of all, the user can start the Zowe sample API service, which is acting as the backend service for this project. Then go to the project main repository containing code for the API, CLI, and VS Code extension, that is the Zowe client sample apps. Open it in Visual Studio Code. Run your extension. When you run the extension, find and open the config folder containing two files, zowe.config.json and zowe.schema.json. These two files contain the connection for the backend service for the Zowe sample API service. The config folder can be found in the workspace folder, that is the Zowe client sample apps. Then open the command prompt and run the command hello world. It will prompt for an input asking you your name. Write your name and the VS Code extension will return with a greeting message. The GitHub repository. Project's main repository is found in the Open Mainframe project Zowe Explorer extension templates, and the repository containing all the code is hosted